Okay, returning to the instantaneous velocity from the first video, we determined that we could approximate what was happening to our car's velocity, how it was changing, how fast we were going when t was equal to 3. Okay, if we did an average velocity, but we only had data an hour beforehand and an hour afterwards. We could do an average velocity using that interval, but that's a very large velocity, and a lot of things can happen in an hour to change our velocity. Traffic jams, police officers, rest stops, all this stuff going on that's going to change what our velocity is. And we really don't have enough data to come up with an exact value at t equals 3. Okay, so what did we need? We determined that we needed more data. All right, we needed more data. We needed that data to be closer to 3. So let's say that more data is available. Okay, let's say that we know, in addition to the points that were given to you on that first sheet, if we're flipping over to the second sheet of the notes here, let's say that we also know that at the 2:30 mark, when t is 2.5, so 2 hours and 30 minutes into our trip, we know that we've traveled 160 miles. So we have that data point, 2.5, 160. And we also know that at the 3 hour and 30 minute mark of our trip that we've traveled 2 hours. Okay, so I'm adding more data. Sorry, 200 miles. I'm adding more data to our overall picture. Okay, and if we put those points onto our curve, all right, we have 2.5 and 160, and then 3.5 and 200. All right, so we're starting to see more and more of a curve appear here. It seems like we have a function which is doing that, if we were to connect all the dots. Now, we don't know if the pink curve is actually what happened, okay? There could be, again, a lot of things that happen during those half-hour intervals, here and there, okay? So, but it seems like this is happening, okay? And we know that the first time around, when we were doing our slopes, we found the slope from 130 to 180. So we found that slope. That gave us our 50 miles per hour. And then we said, well, we also could have found that slope right there. That gave us our 40 miles per hour. Okay, so we found the slope of those lines. Those lines are called secant lines because they cut through our curve at 2 points. Okay, and there is a little bit of margin of error there between what it seems like the curve is doing and what our actual secant line, our slope that we found, actually was. So what do? We try and get it so that the secant line is a little bit closer to the pink curve. How do we do that? Well, we get our data closer. All right. So now what we're doing, instead of finding the slope of that line that I'm racing right now, we are now closer to our actual point. So we don't have as much space between the black approximation that we're doing and the actual pink curve that seems like what's going on. Okay, what are we ultimately doing with our numbers? Well, we're still going to use our 3 and 180, but now we can use our 2.5 and 160, or we can use our 3.5 and 200. Okay, we can use either one of those data points along with our 3 and 180 and get a better approximation of what's going on. Let's just do the first one together. I'll leave the second one to you. But if we do the first one, we have 180 minus 160. Again, we're doing our y values in the numerator, 180 minus 160, over 3 minus 2.5. Those are our corresponding x values. 180 minus 160 is 20. 3 minus 2.5 is a half, and a half goes into 20 40 times. So you see, we have an approximation of 40 miles per hour. Can you do the approximation from 3 to 3.5 and see if you can come up with the idea of 40 miles per hour there as well? Okay, take a second and do that, please. You can pause the video. Okay, so hopefully you're able to calculate that as well. So now we're seeing that we're a little bit closer. We're getting a little more of an idea of what's happening at the 3 hour mark. But again, that's still a half an hour away. All right, 2.5 is 2 hours and 30 minutes into our trip. A lot can happen between 2.5 hours and 3 hours. Okay, so what do we need? You guessed it. We need more information. We need to get closer. We'll talk about that in the next video.